Welcome friends to my channel. Now in today's lecture I shall going to discuss Ampere's circuital law. Ampere's circuital law. Okay, that is the fourth lecture of electromagnetism. Now what does this law states? Now this law states that the amount of work done in taking a unit north pole, say once round a closed path, which is linked with a current say I, is equal to mu naught times the total current enclosed by the path, that is mu naught I. Okay, so if we take a unit north pole, okay, and just rotate it in a closed path, then we have to perform some amount of work done. Okay, so this gives that amount of work done. So work done in taking a unit north pole once around a closed path linking a current I is equal to mu naught I. Okay, so mathematically how we can represent it? Mathematically we can represent it by the line integral of magnetic induction field B. Okay, so this is the mathematical expression of Ampere's circuital law. So the line integral of magnetic induction field once on the closed path, okay, and that path is linked with a current I, so it is mu naught times the total current enclosed by the path. So this is the mathematical form of Ampere's circuital law. So here we have to know a few things. Okay, so what are the things? The first thing, that is, say this is the closed path. Okay, say this is the closed path. So if this closed path does not link with a current, that means current is zero. So clearly we can write B dot dl is 0. If no current is linked with the path. Okay, so this is the first thing. If no current is linked with the path, so that means the this line integral becomes 0. Okay, first thing. Now another thing that would happen, that if the closed path contains a large number of branches, like say this, and each of branch carries current in different directions. Okay, say this current, and this current. Say this is, if we take it plus I, so we have to take it minus I conventionally, and this also plus I. So if this happens, that the closed path contains large number of branches and each branch carries a current, okay, conventionally in different direction, then what happens? We have to take the net sum of the currents flowing through the each loop. So for several branches carrying current in different directions, so we can write this line integral B dot dl. So mu naught I means, so we have to take the sum. So if we take the upward current as plus I, so we have to take the downward current as minus I, and this is also plus I. So the answer is mu naught I. So for several branches carries current in different directions, we have to take the net sum of all the currents. Okay, so this is the case. Now another thing, that can be possible, that is if the loop is a circular one. Say this is a circular, okay, say this is a circular loop, so there are n number of terms, okay. So for a circular loop, say n terms, okay, for a circular loop of n number of terms, so we can write line integral b dot dl. So what would be the total current in this case? Current through each turn is I, so current through the n turns is ni. So this is the case, okay. So in today's lecture I shall discuss the Ampere's circuital law and its explanation, okay. Fine. Now in our next class I shall discuss about the few other issues related to Ampere's circuital law, okay. So dear guys, if you don't subscribe my channel, then kindly subscribe it, and if you like this, then also make a like, okay. Thank you.